Am I on? Oh, there we go. Cool. Hello, I'm Emily, and I'm very honoured to be speaking here today. It's actually my very first data engineering conference. We don't really have a community like this in New Zealand, so super excited to be over here for it. As you can tell from the title of my slides, I've had a rather interesting journey into data engineering, and today I want to share with you some of the lessons I've learned building data pipelines at 3 very different startups. But first, a few disclaimers. 1, opinions are entirely my own. I've forged my own path in data engineering, so if you don't agree with me, that's fine. Let's have a chat over drinks after this. And number 2, for hopefully obvious reasons, I can't go into too much detail about what I did with the rockets, but I will try my best. So a little bit about me. I am a cyclist, a horse rider, and according to an expensive piece of paper that I am still paying off, an electrical engineer. During university, I interned at Trade Me Motors, which is the equivalent of car sales here in Australia, where I got the first taste of data science. Back then it was called Business Insights, and I was helping to build data pipelines for car dealer data. Then I went and actually worked in electrical engineering at an engineering consultancy called Flexware, where I would wire up tree harvesters and various other heavy machinery. From this, I decided to specialize in power electronics and machine learning. Machine learning was very much the cool kid on the block at this point in time, and I was like, yeah, I want to do that. This set me up really well to land my first job out of university at Rocket Lab. Rocket Lab is New Zealand's SpaceX without the problematic CEO. This is obviously the rockets part of my story. After Rocket Lab, I landed a job at Halter, the cows part of my story. Halter is an ag tech startup that basically builds FitBit for cows. And lastly, where I am now is at Multitudes. We're a dev analytics tool, and we create actionable insights to help create happier and higher performing teams. But I'll go a bit more into the last 3 throughout my talk. So, rockets. At university, I studied machine learning, learned a lot about how to build a neural network, how to train it, how to create your data set, validate it, etc. I joined the propulsion team at Rocket Lab as a software engineer, where they wanted me to solve a bunch of data problems with testing their engines. And the following was posed to me. We want to predict engine issues before they become a problem. I was like, great, cool, where's my nicely curated data set that I can use? I can build some models, I can detect some stuff for you, it's gonna be great. And they were like, oh, no, we don't have one. We have like a spreadsheet over here, but we don't have a data set. And I was like, oh, university lied to me. So basically I was like, okay, I guess we have to build a data set. So at Rocket Lab, they obviously launch rockets. On the rocket, there's 11 engines that have to be tested by the propulsion team. So the use case, we need to test these engines before they go on the rocket. Are they working correctly? And we also need to compute some parameters to flight to make sure that they operate correctly. There is a lot of engines. There was only a few test engineers. And it's very laboursome to review all of this data. So they wanted to be able to improve this with some cool data science. In terms of the actual data, the rocket engine goes on a test stand, which you can see in the photo. We fire it up, run it for a certain amount of time, and log a whole bunch of data. The data is anywhere from like hundreds of kilohertz to thousands of kilohertz from various sensors. We're talking pressures, flow meters, accelerometers, stored in various places on the engine computer, local servers, and hideous proprietary control system software file formats. Just the absolute worst to parse, would not recommend. Data had to be processed after every test, which meant it had to be quite fast at processing, so the engineers could look at it and decide whether or not that the engine was okay for flight. In terms of the tech, we weren't allowed to use any cloud software or open source packages, so everything was on-prem. We had to build it from scratch ourselves, self-managed databases and servers. So I got very good at doing all of that stuff. And then data processing was done in very vanilla Python. I was just straight out of uni, so I didn't really know a lot of technologies, and they were like, you just build it, it's fine. And then data was stored in Postgres in a timescale DB, and then shown to the engineers on a .NET application. Now, one of the most memorable moments in my career to date was watching the second launch of the Electron rocket, knowing that my code and data pipelines had computed the parameters for flight and also verified those engines. But also knowing that my code had computed the parameters for flight and verified those engines. So it was a very nervous watch in the mission control room with my team, knowing everything that could go wrong, but it launched without a hitch. We were pleasantly surprised, and it was Rocket Lab's first successful launch. So it was very, very amazing to be there for that. Thank you. They've launched like 40 now, so they're just doing it all the time. So at Rocket Lab, we managed to build this data set. We wanted to ideally use anomaly detection or something like that to be able to detect all these issues and things before flight. Unfortunately, I left before I could actually do the data science because I joined the next exciting prospect, which brings me to the cows part of my story. I joined Halter in the very early days. It was an opportunity to start at a company much earlier. And I joined as a data analytics engineer, still wasn't quite identifying as a data engineer at that point. And I was like, I want engineer in my title. I paid a lot for that degree. I want to be an engineer. So I was a data analytics engineer, and the following problem was posed to me. We want to predict cow behavior and pick up on issues before it becomes a problem. So at this point, still being quite naive, I was like, you're far along. Where's my nicely curated data set? They don't have one. Okay, all right, okay, I guess we're building the data set, fine. There's no data set in the world that has cow behavior. So at Halter, the cows wear collars, which you can see in the top right of this photo. And the collars basically tell the cow when it's time for milking, keep them inside a virtual geofence, and also let the farmer know when it's time for breeding. I won't go into too much about that. But also they log data for cows. So we want to be able to predict cow behavior. Are they sick? Are they lame? Are they eating? And in order to do that, we need to be able to have data to improve the cow well-being. So in terms of the data, the collars would log at around the tens of hertz and send data back over a radio network that was installed on farm at various intervals. And we also had special data collars that would log at higher frequencies, and then they would ship it in the milk shed over Wi-Fi. In terms of the data, we had GPS and IMU data, which is magnetometer, accelerometer, and gyroscope, basically to look at movement. But of course, in machine learning, we need labels. What does a grazing cow look like? So cue us hiring a bunch of analysts called the cow behavioralists that literally made labels watching cow videos. So you can see the van up in the photo. There was a generator and on there, a server inside it, and a bunch of security cameras that would be driven into the paddock and watch the cows all day. You can see as well that the cows are wearing coats with little letters on them. That was so that our cow behavioralists could identify the cow in the video and then link it up to the collar and say, yes, cow 00 was grazing at this point in time, and we could know what a grazing cow looks like. In terms of technology, thanks to an amazing DevOps engineer, I was ingrained into the wonderful world of AWS. Didn't have to do my own databases anymore. Yay. We use AWS Kinesis data streams to stream in the data from the collars, and then AWS Glue, which is AWS's Spark as a service. So we'd use PySpark for all the data transformations, and then Athena to store the raw and processed data. We would then look at the data in Tableau, and then eventually hopefully use something like SageMaker to build the machine learning models. Once we built this nicely curated data set with what a grazing cow looks like, it was like, cool, okay, cool, build the model now. And I was like, I kind of don't want to. I realized at this point in my career, I really enjoyed building data pipelines. I didn't realize this was a job that you could have. I just kind of had to do it to get to the data science. So I was like, and we hired a data scientist, and they now do all sorts of cool grazing pasture detection at Halter. So I enabled that, but then I moved on to the next thing, which was the developers. So I joined Multitudes as a founding team member as the lead engineer. At Multitudes, we plug into tools like GitHub, Jira, etc., and provide actionable insights to create happier and high-performing teams. So when we got started, the following was posed to me. We want to predict team behavior and performance before it becomes a problem. Now, by this point, I was under no assumptions that there existed a nicely curated data set. So I was like, okay, we have to build it. I have a blank canvas. I've got some skill set. So let's build it. So in terms of the use case, teams generate a lot of transient data from software tools that they use. And this data can be used to help improve team collaboration. Are we delivering fast enough? How is the team reviewing code together? Are we actually increasing delivery speeds, but at the expense of someone doing more out-of-hours work? So how can we help to improve that just using data, not having to do surveys or anything like that? In terms of the data, we plug into our customers' GitHub, Jira, Linear, OpsGenie, etc., and get data in real time. This is things such as when a pull request has been reviewed, an incident has been resolved, or a Jira ticket has been marked as done. We then process this data every 6 hours, contextualize it, enrich it, and create insights and actions that we can show to our customers to help them and their teams do better. In terms of the tech, I've come a very long way. But as you'll hear in a moment, we didn't start with this kind of tool set. But I feel like we are using some of the greatest tools in data engineering. A lot of them I've learnt the hard way. Even being here today, I'm like, oh, I really want to try that and that and that for the next evolution of our data pipelines. So we use a lot of lambdas, which we'll also hear about in a moment, using AWS step functions to orchestrate those. We use ECS, which is AWS's Docker as a service for a lot of data wrangling. Then dbt and Snowflake for transforms and storing data in various states. And then a little bit of Python to enrich the data, apply our business logic, and send the data to our APIs, where they're then stored in Postgres. Close to my heart, I love Postgres. And then that's displayed to our customers on our app and also via Slack notifications. So I can finally say I've built a really nice data set that I am now using data science for. One of our data scientists is here, actually. Hopefully he can attest that it's good data. So we've actually just started on our AI journey. We've been looking into LLMs and generative AI, as everyone is doing. And actually just yesterday, we released our AI coach. So customers are able to talk via a Slack bot to get at-time insights about their team and how they can help speed up delivery or check in with people. So yeah, very glad to get to this point and actually stay at a company long enough to see the rewards. But what were some of the lessons that I've learned along the way in this very tumultuous journey? Lesson number 1, just build it. I know there's so many tools out there. Every day there's new tools. But you could spend forever looking into the exact right tool that's going to solve your exact problem. But you don't need fancy tech to start. You can build up to the fancy tech. So what's some tips for doing that? Well, as I mentioned, I love lambdas. They're small snippets of code that execute very quickly. They're very cheap. My team will probably say, I love lambdas a little bit too much. Like, Oprah, you get a lambda, everybody gets a lambda, yay. There is such thing as too many lambdas, I have learned. But things like step functions and queues, things like that can help you better orchestrate them. I know as well there's plenty of cool data engineering tools out there that I should really look into that would probably do a very nice similar thing. Secondly, use the languages and frameworks that you know. There's no point spending all this time researching into Go because it's the coolest new language if you don't know Go and your team don't know Go? At Rocket Lab, I should say, I knew Python. That's all I knew coming out of university. So I just very iteratively built the pipeline using Python, kept it very simple, and it did the job. At Multitudes, same thing. Our data pipeline actually ran on a Python Lambda for quite a while. I would run on a Sunday, process all the customer data, done, dashboards, set, everything. Obviously now it's a lot more developed because we ran into timeouts and memory issues, but you can start small and then build on that. And then, really important, get to know your customers. So for the rockets, I became a test engineer. I would sit there, I would run through the operations of the test, I would test the engines. I would watch the test engineers use my pipelines. I would watch them use the code and see how they were doing it. I even read the rocket scientist Bible from NASA so that I knew more about the parameters that I was computing. Like, what do they mean? How do I compute them? What's the kind of range of values I should be expecting? For Multitudes, kind of cheated a little bit because I technically have worked in development and am a developer, sort of. But I still sit on customer UX calls whenever I can. And at Halter, I became a dairy farmer. I would bring the cows in for milking. I would see what was happening for grazing, for milking, etc. I would milk cows. I became a diesel mechanic because I had to fix the generator when it went down because we'd lose video footage otherwise. And became a security camera expert. So if you ever need, your house wired up with security cameras, I got you. The software is terrible, but I know how to use it. So yeah, really get to know your customers and the domain that you're working in so that you can build the right products for them. And maybe your data customers aren't external. Maybe it's your data science team, maybe it's your analysts. Really work with them and figure out what they need to know so that you can build something that works for them as well as you. Lesson number 2, automate and codify it. Because no one wants to be spinning up data pipelines manually or testing in production. So what's some tips for automating? Highly recommend just terraforming all the things. This is infrastructure as code. If you're lucky, you may have a DevOps team that just writes Terraform for you, which I'm very jealous. So for the cows, I worked with our amazing DevOps engineer and learned Terraform, how to build data pipelines in AWS and Snowflake with Terraform. Everything was version controlled, and it's a super, super useful skill to have for a data engineer. It works well to then have multiple separate environments. So isolate your dev, staging, and production environments, which also means you've isolated your dev, staging, and prod pipelines. You can test everything, full infrastructure, everything in dev and staging before you release to production. At Rocket Lab, I wish we had this, because we would very much test in production, where testing in production was like turning on the rocket engine and seeing that it worked. So I've since learned, make sure you just test in dev and staging. At Multitudes, we took the same sort of thing as I did for the cows, where we have completely isolated environments and can be sure that data is safe. As part of that as well, unit and end-to-end test things where possible. I know testing can be laborsome and tiresome and seem really unimportant at the time, but it absolutely pays off in the future rather than trying to apply tests to spaghetti code and figuring out what's tested and what isn't. Becomes very useful when you are testing in production with a rocket engine and you are off by a factor of 10 and you maybe almost kind of blow up a rocket engine. It's fine. Test yourself, okay? It's fine. Number 3, as much as software engineers would love to believe it, I personally believe there's no such thing as schemaless. I've heard a lot of things today which verifies that point of view, so thank you. Even if you bring in your JSON data and then you read the schema, that's fine. But everything needs a schema eventually. You can't just put all this data in a data lake and hope for the best. So what's some tips for managing schema? Well, don't be like this guy. Have a schema, please. Document the data at each stage. What does the raw data look like? What does the processed data look like? What does the enriched data look like? What units is it in? What frequency? Where does it come from? At Halter, a little bit of just dump everything into S3 and it'll be fine. And I spent a lot of time categorizing all of that data, figuring out where it came from, the units, etc., and wrote basically the Holy Bible of data for cows. And that was the most loved wiki page in the company because everyone could go there to find the information that they needed. Now, wiki pages obviously aren't the best for this, so also version control your schema. For developers, we use tools like DBT, so we can have all of our schema and transforms and YAML files, and we can check them into GitHub and see what changes are happening. And lastly, this became very important at Multitudes, where we don't control the data architecture, right? We're reading in data from all these different platforms. We have no control over this. Split your data based on event type or source. Don't just chuck it all into a data lake and hope for the best. Pipe it all out into, the domains, into the particular data type that it is, where it came from, so that you can then have a nice schema and a nice table without a bunch of random nulls everywhere. Number 4, secure it. I know as data engineers, we don't think this is our job, but I've gone to too many hacker conferences to believe that anyone is too small for hackers. It's much easier to put security practices in at the start than try and squish them in once processes are ingrained. So what are some things to think about? Hopefully, when it's not too late. Number 1, kind of around data governance, but who has access to this data? Does the product team need access to raw customer data? Probably not. Does the data science team need write access to customer data? Probably not. I recommend following least privileged access for data. This way you know exactly who has access, and you don't have to try and put all these controls in later. Obviously, don't go too hard. If your data scientist is asking you every second day for access to a particular data set, you've maybe gone too hard. But if they're asking you every second month, it's probably about right. Something very important for developers, we obviously process a lot of data, and that data is personally identifiable. Do you really need to store personally identifiable information if it's not going to benefit your product? So we try and strip any PII before it comes into our system, and then use things like IDs to link up all the things that we need. That just saves you a whole lot of headaches later on if you don't actually need it. And lastly, with all these tools out there, it's super easy to just encrypt stuff at rest and in transit. With AWS and Snowflake, sometimes it's just a toggle. Often it's just by default that data is encrypted at rest. So would highly recommend looking into that, making sure your data is encrypted, and also rotating the keys every now and then, just in case. In terms of, what was I saying? Oh. Number 5, make it ethical. Much like security, data ethics starts at the beginning. And us as data engineers have the power here. We're the ones that are that are building the data, transforming the data. And now is the time to do it. It's easy to gloss over it and think it's someone else's job, but in a small company, what you're doing now at the very beginning is going to help immensely in the future. This is mostly what I've learned at Multitudes, because the data that we're processing in its nature is particularly sensitive. So what are some of our data ethics principles? Now, these principles we have formed ourselves. We took a lot of inspiration from Indigenous data sovereignty policies because, unfortunately, Indigenous people are some of the groups that have been harmed by the misuse of data the most. As Kendra said in her talk this morning, people don't intend to cause harm, but sometimes without thinking about it, we do cause harm. So what are some of the key principles? Number 1, autonomy. We give people control over how their data is used. At Multitudes, even if your whole team is on the platform, you're able to opt out so that we do never process any of your data, and you don't have to be part of the product if you don't feel comfortable about that. Reciprocity, just because you can doesn't mean you should. We only collect data that we can give value from. We don't want to collect all of these 1 million data fields because they may be useful someday if we're actually not going to provide value from it. This probably also will get really expensive, and you just don't need it. Collective benefit. We want to create a positive impact for cows, rockets, and developers. We don't want to cause harm for the data. Also, data can tell a lot of stories, and it can tell a lot of lies. So we help people put data into context. Maybe A team has been delivering really, really fast. They've met all their goals. It's been great. Code is out. Features are out to customers. But we see that also well-being has decreased. There's been a lot of out-of-hours work. So we help to support putting that into context, looking at all of the factors that could be going on. And lastly, there's no point having these principles if you don't get held accountable for it. So we encourage people to tell us when we make mistakes and if we're not following our own data principles. In terms of how we put these into practice, I know we're a small startup and it seems maybe a little bit like too much. All we do is when we're building a new feature for customers is we talk through each of these 5 points and assess how that feature meets all of these. If at any point it doesn't or we feel uncomfortable, we don't build that feature and our customers win, we win. So I really recommend looking into data ethics and reading up about Indigenous data sovereignty because there's a lot of really good stuff there. And we as data engineers have the power here to make sure data is used for good. So the TLDR, 1, just build it, whatever it is, I don't care. Automate and codify it, don't test in production. 3, there's no such thing as schemaless. Make schemas, please. 4, secure it, not too small for hackers. And 5, make it ethical. So, in the end, what do cows, rockets, and developers all have in common? Well, yeah, CO2. Yeah, not good. Well, developers probably better for the environment than cows and rockets. But they all create data, and that data can be used to be useful to improve their daily lives. We as data engineers are so lucky to work in such a cool industry where you can work with cows and rockets and developers and use your skills to help all of these different industries. You know, I've been able to use my skill set and build it up at these 3 very different startups, but still use the same lessons, apply the same techniques. Now, AI is becoming more and more ingrained in our everyday life, and we as data engineers have the power. And in the words of Spider-Man's Uncle Ben, with great power comes great responsibility. I'm Emily from Multitudes. Thank you very much.